Hello, today we will have a look at Docker networking without going to OS level details. Having conceptual knowledge about Docker networking will help to take full advantage of containerized applications in cloud-native world. Moreover, it is must to select correct networking mode and apply proper configuration for production deployment. By means of dedicated channels between Docker containers, one container can consume web services of another container or simply transfer or accept files. It makes service mesh possible between containers. Docker networking consists of several drivers and they provide different core networking functions. Now, let's go over them one by one. Before going forward, let's have an understanding about some of Docker concepts. A Docker host is physical computer system or virtual machine where operating system is running in normal non-container mode. The Docker daemon is always running process which exposes Docker API and manages Docker objects such as images, containers, networks, and volumes. A daemon can also communicate with other daemons to manage Docker services. Let's start with default bridge network. If you don't specify a driver, Docker engine automatically chooses the default bridge driver while creating network. Bridge driver is single host networking driver, and it is limited to local host. Bridge network allows standalone containers on the same host to communicate each other while still applying isolation. All new containers will be joined to this default network. From Docker host, you can ping the container IP address in this networking mode. Host network. In Docker host networking mode, Docker containers shares its network namespace with the host machine. In other words, application inside the container can be accessed using a port at the Docker host's IP address. Host network fits well if container network stack should not be isolated from the Docker host, but other aspects of container to be isolated. Network namespaces a bit abstract but important feature of Linux kernel, which makes inter-container communication possible. Let's say a couple of words about it. Linux network namespaces are Linux kernel feature allowing us to isolate network environments through virtualization. A container can be considered synonymous to Linux network namespace. For example, using network namespaces, you can create separate network interfaces and routing tables that are isolated from the rest of the system and operate independently. Network namespaces have their own interfaces, routing tables, loopback interface, and IP tables rules. You need to create these resources for your namespace. You can connect different namespaces to each other by creating Linux bridge and virtual Ethernet device. Overlay network. The overlay network driver creates a distributed network among multiple Docker daemon hosts. This network sits on top of the host-specific networks and allows standalone containers sitting on different daemons to communicate each other. When encryption is enabled, it also ensures secure communication. This strategy removes the need to do OS-level routing between containers. IPVLAN as driver for virtual network is used in Docker environment to access the host network. IPVLAN exposes a single MAC address to the external network regardless the number of VLAN devices created inside the host network. User can have multiple IP VLAN devices in multiple containers, and the corresponding switch reads a single MAC address. IPVLAN driver is useful when the local switch imposes constraints on the total number of MAC addresses that it can manage. Docker IPVLAN networks give complete control of Layer 2 VLAN tagging and IPVLAN Layer 3 routing for users interested in underlay network integration with IP version 4 and IP version 6 support. I want to say a couple of words about overlay versus underlay networks and VLAN tagging. While overlay is logical network using tunneling encapsulations, an underlay network is the physical network responsible for the delivery of packets like DWDM, Layer 2, Layer 3, MPLS or Internet. When Ethernet frame traverses a trunk link between switches, a special VLAN tag is added to frame and sent across the trunk link. By looking the tag, the frame is sent to the correct access link port according to the switch table, so that receiving end is unaware of any VLAN information. Let's also have a look IPVLAN Layer 2 and Layer 3 modes quickly. Layer 2 mode. Virtual devices receive and respond to address resolution protocol requests. Using Layer 2 mode provides good performance but less control on the network traffic. Address resolution protocol used to translate between Layer 2 MAC addresses and Layer 3 IP addresses. IPVLAN Layer 3 mode. Virtual devices process only Layer 3 traffic and above. Virtual devices do not respond to address resolution protocol requests, and users must configure neighbor entries for the IPVLAN addresses on the relevant peers manually. Using Layer 3 mode provides good control but decreases the network traffic performance. As a last network driver, we will discuss MACVLAN Network. MACVLAN networks allow you to assign a MAC address to container, making it appear as a physical device on your network. The Docker daemon routes traffic to containers by their MAC addresses. Using the MACVLAN driver is sometimes the best choice when dealing with legacy applications that expect to be directly connected to physical network, rather than routed through the Docker host network stack. Selection of correct network mode as Docker networking driver plays a crucial role in the production-grade system design. During the development phase, constraints, policies, and infra limitations can be omitted, but when the end-to-end integration is started, best-fitting networking mode should be applied to achieve container communication. Apart from Docker-provided network drivers, there are also third-party vendor plugins that allow integrating Docker with specialized network stacks. VMnet legacy plugin can be given as sample. It is also possible to disable all networking at all to use custom network driver. I hope that I could be able to shed light on Docker networking topic, which is important integration step to pay attention while going to production with containers. Thank you for listening.